Okay, so how's everyone? Chavi, Manan, Ruchika, can you guys hear me?
Yes.
Yeah, sir.
Wonderful. Anything that you guys want to discuss? Any questions that you have before we get started?
So I had one question.
Okay,
So how, it's a little complicated, so I can't just tell it like verbally.
okay,
Can I just send it to you?
sure, beta.
Yeah. So,
WhatsApp kar de and then
huh.
take it up. Ruchika, Manan, do you guys have any questions? We're gonna get started with relative motion today. So we are going to talk about the relative motion. So we're going to start with the relative position. We'll talk about relative velocity, and we'll look at different scenarios for that. Okay. So Chavi has a doubt. Let me see if I can bring that doubt over here. Okay, so let me just quickly paste it. It says an object A. Is it? Can you guys read it? Can you guys see it?
Yes.
Okay. It says an object A is kept fixed at the point x is equals to 3 meters and y is equals to 1.25 meters on a plank P raised above the ground. At time t equals to 0, the plank starts moving along the plus x direction with an acceleration of 1.5 meters per second square. At the same instant, a stone is projected from with a velocity u as shown. A stationary person on the ground observes the stone hitting the object during its downward motion at an angle of 45 degrees to the horizontal. All the motions are in xy plane. Find u and the time after which the stone hits the object. Okay. So, Chavi, do you want to talk about how you approach this question before we dive into it, and where was your struggle, beta?
So I think I got confused because there's so many different things going on. But what I didn't understand was if this is the initial position, eventually the AP the object would move front, obviously, and the like I was able to draw the diagram, right, and
Okay.
I was able to get some equations, but I got stuck somewhere.
Sure. So let's first understand what's going on and then we can worry about the equations. Okay. So what is happening is at t equals to 0, this platform P starts to accelerate in the rightward direction, let's say, with a constant acceleration of 1.5 meter per second square. Okay. And the block object A, which is kept on the platform, will accelerate along with the plank. Let me see if my assumption is right. An object A is kept fixed at the point x equals to 3 and y equals to on a plank P raised above the ground. At time t equals to 0, the plank starts to move, blah, blah, blah. A stationary object, okay, observes the stone hitting the object during its downward motion. Okay. So the A is moving along with the platform, and the projectile hits it during its downward motion. And during the downward motion, it makes an angle of 45 degrees with the horizontal, which means that the platform P or the object A has traveled this distance. Yes, Peter?
Yes, sir.
Okay. And they're asking what is the u vector? That means we need to find the initial velocity and the angle theta to be able to find the u vector. And the time after which the stone hits the object. The time after which it hits the object. So the equations would be, so now quickly talk to me about the equations where we had the struggle with the equations. What was the struggle there? So you wrote the equation for platform P, right? So it has a horizontal acceleration. So you can write the horizontal direction, distance s or distance x, whatever that might be. This is equals to ut. U is 0 for this one. So half a t square, right? So we have to determine t, time t. Now in the same time t, the projectile flies over and it reaches this point. Okay, so this is also at the height 3 meters. Because of the shear symmetry, just note that the projectile is going to pass through its original point as well as this point. Okay, just an observation there. Yes, Vida?
Ha, sir.
Okay. Now, if you were to write now what else is given for the projectile? The angle that it makes. So what does it tell us? If you look at the velocity, if you say the velocity is v at that time, so that means vy by vx is tan 45, that is 1. That means vy is equals to vx at that time. What is vx? U cos theta. What is vy? Vy is uy, that is u sine theta minus gt. U sine theta minus gt. Correct, beta? So
Ha, sir.
how many unknowns are there? There are 3 unknowns. What are those unknowns? U, theta, and time t. And we have to determine all 3. All 3 are being asked. Right? So we just need to find 3 good equations, 3 independent equations to be able to solve. And there might be some mathematical jugglery involved as well. What is the second thing? Now, so we got this one equation. Now the distance traveled, so this is 3 meters. So the distance traveled by the projectile is how much? S plus 3. So in fact, let me write it for the platform first. So S is equals to half a t square. Now I've introduced another variable. So this is another variable now, S. So what is the third equation? So we should have 4 equations now. So what is the third equation? Third equation is the distance traveled by the projectile is S plus 3. Yes, Peter? The horizontal distance. And that'll be equals to u cos theta into t. What about the vertical distance? It is 3 meters.
Wait, so I didn't understand how you got S plus. Oh, okay, okay, I got it. Yes, sir.
By the way,
Got it.
this is 1.25 meters, not 3 meters. The vertical distance is 1.25 meters. The vertical distance is 1.25 is equals to vertical distance u sine theta t minus half gt square. Okay. So as long as we can agree that these are the 4 equations and 4 unknowns, then we can proceed further to maneuver around and figure out the time t and u and theta. Peter, would you like to take the opportunity at home and take it from there? Take it.
Yes, sir. Yes, sir.
Okay. So have fun with these equations. So hopefully there'll not be anything funny in there. We should be able to find it. But once again, there were 3 unknowns that the question is interested in, that they want us to find. The way we were writing the equation, we end up introducing one more variable, which is S. But we got 4 equations. 4 equations, 4 unknowns. We should be able to solve them. Yes, that simple. That's it.
Yes, sir.
Okay, good. So we are getting into the question types on relative motion. Now the question types on relative motion within the website they are built into a couple of different question types, right? So for example, the one that we will be coming back to is basics of relative velocity, relative position of two particles moving at the same acceleration, relative position of two particles, and then we will have relative velocity, then minimum distance. So these 5 question types, in fact, not just 5, there are a few more. Swimmer in a river problem, and then the Rain Man problem, which I believe is tucked in inside one of the other question types. Let me just see. The Rain Man problem would be, or perhaps this one, the relative velocity. It's right in here. So 1, 2, 3, and then 3. So about 6 different question types we have on relative motion. So we are gonna look at the blog that I sent you guys. So there I have tried to consolidate everything on the relative motion in one place. So let's go to it. Okay. So Manan, just as a quick recap, we will talk about, we'll start off with understanding the relative position, and then we'll talk about relative velocity. So Chavi, relative position was fairly simple and straightforward yesterday, right? So if you talk about one-dimensional motion, then, so let me just draw a quick scenario here. Okay, that's not what we wanted. Something has gone wrong here. Give me a second. I think this is zoomed in. Okay. Wow, something is definitely not right, but that's okay. Is it readable or is it hard to read? Let me see if I can zoom in. It should be better now. Okay, so let's start. So if you have in a one-dimensional motion, let's say this is my origin, and let's say this is particle A located at x is equals to -2, and then I have particle B located at x is equals to +4. Then what is the relative position? Because relative position is also a vector quantity, right? It's also a vector quantity, which makes sense, right? So if you have somebody sitting around you, you will say this person is sitting in front of me, or to my right, or to my right and front, right, to my north, east, whatever that might be. So beta, in this case, if you were to quickly tell me the relative position, the position of B with respect to A, what will that be? Will that be +6 meters? Yes, beta? Relative position of B with respect to A.
Yes, sir.
Okay. So I'm going to write it as relative position of A with respect to, of B with respect to A. What will be, and anybody can answer, I'm just going to pick on Chavi for no reason. So XAB will be what? How much? This is position of A with respect to B. What will this be?
-6.
-6. So what is the mantra here? Mantra is XAB is position of A minus position of B. Okay. So if both are in the negative sign, just as a building up our immunity here, this is A, this is B. So what will be x of A with respect to B and x of B with respect to A? So what will be the relative position of A with respect to B? Relative position of A with respect to B.
So 2 plus 2.
That will be plus 2. Yes. That will be plus 2. What will be the relative position of B with respect to A? Relative position of B with respect to A, we are talking about this scenario.
So minus 2.
Minus 2. And for the students who are joining us on the YouTube, Brajpal, hi, beta, I hope you are following the discussion. We are working on kinematics. Within kinematics, today we are focused on relative motion. Okay, moving on. Let's talk about two-dimensional motion, right? So let's say, Beta Manan, can I ask you a question now? So let's say A is at some coordinates 2, 3 and B is at 4, 1. Then please tell me the relative position of A with respect to B and relative position of B with respect to A. I'm picking on Manan, but anybody can answer. Anyone can answer. Looks like Manan is having some issues there. So Ruchika, if you want to take a stab at it, beta, please do. Relative position of A with respect to B. Let's start with that first. What is the relative position of A with respect to B?
So minus 2, 2.
Minus 2, 2. Minus 2, 2. If I were to draw that vector, this is how that vector looks like.
Yes.
Position of A with respect to B. Simply put the tail of the vector at B and the head at A, right? Now, if you guys are familiar with the vector algebra, then if you were to draw the position vectors of A and B with respect to the chosen coordinate system, so this is your RA and this is RB. And by the way, what is RA? Just quickly, which obviously you've answered this, but still I'm going to write it down. So RA is 2i cap plus 3j cap. What
Yes, sir.
position vector of B? Simply the x coordinate. If there are three vectors, like this, which the tail of one is on the head of the other, and the head of the vector is on the tail of the other vector, and they form a triangle, then the sum of the three vectors will be 0. Sum of the three vectors will be 0. So if this is A, this is B, this is C. It's kind of logical as well, because if you just think of these vectors as the direction vectors, right? Your position vectors in let's say the city that you are in, then if you were to walk along A, then walk along B, then walk along C, you'll come back to the starting point, right? So the sum of the three vectors the resultant vector would be the 0 vector. Now if you use that logic, and I hope you're familiar with a negative vector, right? So if I were to write this as A plus B, so this vector is A plus B plus C is equals to 0. So I can write A plus B is equals to minus C. What will be minus C vector, beta? Minus C vector will be this one. So let me use a different color. Manan beta, you're back. Okay. Let's see. So the negative vector will be this one, beta minus C. So A plus B. So A plus B is equals to this vector in blue, minus C vector. Now compare this with this one, right? So RB plus RAB is RA. In other words, RA minus RB is RAB. Once again, so what I'm saying is RA is equals to RAB plus RB, which means position vector RA minus position vector RB is RAB. And since I've given you the coordinates, you know you can write RA and RB in unit vector notation, that is 2i plus 3j cap for RA, 4i plus j cap for RB. You subtract the two, you get what Ruchika mentioned, that will be minus 2i plus 2j, minus 2i plus 2j, correct? Manan, yes, Namita? Now, beta, Ruchika, you might think that, sir, I know this, these things, and Chavi, the same thing for you, beta. You guys might feel, hey, we know this, right? But the reason I'm still going through it in a meticulous fashion is there are small nuances which mind tends to forget, and in some tricky situation, these things may not be that obvious, right? So anyway, so just patiently kind of listen through it. Okay, so we are clear on the position vectors or the relative position. Then we did a question on relative position. And now let's go ahead with relative velocity. Okay. So let's understand what do we mean by relative velocity, because the concept can be either very simple to understand or it might be very confusing, right? So let's look at this this animation. Let's see if it automatically plays again. Okay, there we go. So let me actually start it from, let me pause it. So at this point, VA and VB are starting from the same point, right? Starting from the same point. Now we talk about relative velocity, and let's say we are interested in relative velocity of A with respect to B. A with respect to B. Then what essentially B is interested in is, right? So what B will be looking at it is not how far A is moving with respect to the ground or any other reference. It is going to see how far A is from itself, right? So let's take an example on the highway, right? So let's say you have your car, you're traveling in a car which is at 60 kilometers per hour, right? And you have another car pass you by at, let's say, 65 kilometers per hour. What will you notice? You will notice that car slowly moving past you, right? Slow enough so that you can see what people in the car are doing, right? It is that slow, right? You can clearly see the faces, you can clearly see what they are doing, what's going on. The relative velocity, because the relative velocity is relatively small. How much is it? Only 5 kilometers per hour. But if you have somebody on the ground, let's say you were standing on the side of the road or the highway at a safe distance, then what will you see? You will just see a car pass you by quickly, right? You will not be able to record much about what's going on with the passengers within the car, because the velocity with respect to the standing observer or with respect to the ground is 60 kilometers per hour. Anyway, so both of these will be moving. So we're going to talk about the velocity of A and B with respect to the ground, stationary observer, and we'll talk about relative velocity of A with respect to B. So keep in mind, what matters for the relative velocity is how far is A from B, right? What is the distance of A with respect to B? And assume that they are, that the distance, even though they are moving parallel to each other, but their distance is not that big, right? Even though I've shown it to be fairly significant, but assume this distance is very small, right? So the two yellow lines are showing the distance of A with respect to B, right? So what will B report? So B will say that actually A has traveled this much distance only with respect to him or her, right? Or with respect to it, if this is an object. Okay, so what will the B report as the velocity? Well, XAB divided by the time duration t, right? And if you talk about the instantaneous relative velocity, then will be how much distance does it travel in a small duration? How much distance A travels with respect to B in small differential time dt. I've said many things. I think you guys are quite familiar, but I'll still want to go ahead and ask any questions you might have. Any questions? See, with respect to the ground, it has traveled distance xa. With respect to ground, B has traveled a distance of xb. With respect to B, A is the position, the relative position of A with respect to B is xab, right? So what matters is, from the relative standpoint, is that number. Yes? So let's write down the expression for BAB. I think this one will not work. I have no idea what's going on. Capture full page. There we go. System seems to be behaving slightly erratically over the last few days. It might be the simultaneous streaming that's going on Google Meet and the other media. In any case, so Chavi beta, you have two trains. One train is moving at 60 kilometers per hour. Another is moving at 40 kilometers per hour. Fairly simple question, but still I'll go ahead and ask it. What is the relative velocity of B with respect to A? What is the velocity of B with respect to A?
So minus 20 kilometers per hour.
Minus 20 kilometers per hour. In other words, A will say that actually B is moving in the other direction, towards the left, with respect to it. Okay. Now let's say the two are moving in the opposite directions. This is A, this is B, this is 40, this is 20. What is the relative velocity of A with respect to B? Velocity of A with respect to B. Or forget that. Let's talk about velocity of B with respect to A. So Manan, what is that number, beta? What is the velocity of B with respect to A? Let's say this is the x.
Minus 60.
Minus 60. So remember this, VB minus VA, that's simple and straightforward. So minus 60 kilometers per hour. Okay. Good. Here is a quick demonstration, even though we understand these things, but sometimes it's fun to watch it, right? Fun to watch it. So what is it showing us? Okay, it's saying the position of A with respect to B. This is the initial, this was the initial, this is the final. Difference of the two will be, difference of these two will be the change in or the displacement with respect to the B. In any case, I think it's clear enough. So let's do some sample problems and then we'll look at some fun problems. Let's look at this number 3, please. What's going on today? Okay, let me know if this is readable. If it is, then let's go ahead and let's attempt this question. Train A and B are running on parallel tracks. Can you guys read this question okay, or is that a challenge?
Sir, it's readable.
It's readable? Okay, beta. Let's go ahead then.
So 29.5 meters.
29.5 meters per second. How much is 36 kilometers per hour in meters per second? Is it 10 meters per second? 72 kilometers per hour is 20 meters per second. Sorry, beta, I was on mute. You got the answer 29.5 meters per second, right?
Yes, sir.
Okay.
Sir,
Chavi?
29.
Yes, beta?
Sir, same answer.
Same answer. Okay. So it is simply 36 minus 1.8 plus 72.
Yes, sir.
Yes.
Don't make me sound like this is fairly simple. I know when you are doing it at this stage, you have to think through it. So do take your time. Do take your time. Okay. Okay. So shall we move? Shall we go to the next question? Shall we? Is that okay? And there is a comment on YouTube. Let me see what that comment is.
Yes, sir.
It says, sir, please keep a series of video for JEE students advanced. Yes, beta, we will be doing that fairly shortly. So if you are planning to appear for JEE advanced in 2022, then we will soon be starting a series where we will go through all the key concepts of different topics. So stay tuned, we'll come to that. This is meant for students appearing either next year or in 2024. Alrighty. Okay. So moving on, let's go to the next question. Let's attempt. Okay, so now we're gonna look at time to collide. I think which is fairly simple. If there's any question in there, maybe there's not a question in there, right? But if I were to ask you, the two trains are this far apart, how long do they take to collide? Then distance, right? The distance divided by the relative speed. right? They'll give you the time. Yes. Okay. I'll take the silence as you guys think it's a comfortable concept. Now let's come down to two-dimensional motion. Two-dimensional motion, and we'll talk about the relative velocity in two-dimensional motion, just like we did relative position in two dimensions. What was that? Relative position of A with respect to B, RAB, is RA minus RB. What is the relative velocity of one with the other, right? So let's say relative velocity of A with respect to B. So let me just see if we can discuss this Feynman problem. Something is really funny with the Microsoft Edge today. I have no idea what this is. That's okay. So relative velocity of, let's say you have A moving like this. Let's say the speed is, Chavi beta, I'm going to ask you this question. Let's say the speed is 2I plus 3J meters per second. Then B is moving at, let's say, is moving towards the minus X direction with a speed of, let's say, minus 2I. So what is the relative speed of B with respect to A? Relative velocity, I should say, not just speed. Relative velocity of B with respect to A. Speed will just be the magnitude of the velocity. Yes? What will be relative velocity of B with respect to A? What will A say? With what speed is B moving? How will A see it? Anyone can answer. Doesn't have to be Chavi. Anyone can answer. What will?
So minus 4 I cap minus 3 J cap.
So essentially this was VB minus VA. Stick to the definition, stick to the basics. We have explained, or at least I've tried to explain, the relative position of B with respect to A. If you take the time derivative, recall what we discussed earlier, right? So what is relative position of B with respect to A? We said this is RB minus RA. If you take time derivative with respect to T, you will get VBA is equals to VB minus VA. Is that clear? Yes, no?
Yes. Yes, sir.
Okay. And what will be the direction of that relative velocity? Can you guys help me plot it? So essentially you added two vectors. One is minus 2I and then minus VA vector. I need to add minus VA vector. Minus VA vector will be something like this. Opposite to the VA vector. This was the VA vector. This is minus VA vector. So the vector sum of the two, right? Use the parallelogram to find out the resultant vector, right? This is the resultant vector, which is, Chavi, what you said is minus 4I minus 3J meters per second. Yes? Okay, so now let's talk about this rain and the man problem, right? Because we all love rain and we all get wet in the rain. So I'm sure everybody's wondering at what angle the rain is falling. Huh? But anyway, so let's see. The rain is coming down vertically. There is no wind. And let's say, Manan, you are running with a speed of 20 meters per second in the horizontal direction, of course. And the rain is falling at, let's say, 20 meters per second, really fast moving rain. Okay. So what will be the direction? So if somebody were to ask you, Manan, how's the rain falling? So what angle will you report that the raindrops are making with the vertical? What will you say, Vida?
Sir, 45 degrees.
45 degrees. How did you do that? So again, rain is a particle, right? Just like A and B. So this is A, this is B. You are interested in V of A with respect to B. A is the raindrop, B is the man. So what is the velocity of A with respect to B? So what is that? VA minus VB. What is minus VB vector? Minus VB in this direction, minus 20. So what is the vector sum of the two? This angle. And because they're both 20, this angle is 45 degrees. Okay. So now typically, depending on the class, depending on the student, sometimes the teacher might want to do more questions to make sure that everybody is comfortable. But I believe that that I am lucky to have good students. So let's give you guys some good problems, okay? So let's see how you guys do. Okay. We will do one by one. We'll talk about A, B, C, D. So let me explain what this is. We'll read this together. Then I'll go silent. You guys can think about it, okay? It says, on a rainy day, a man is running on a hilly terrain in such a way that he is always finding the raindrops hitting him vertically. Got it? He is always finding the raindrops hitting him vertically. It is assumed that rainfall is uniform in the whole terrain from O to E. So rainfall is uniform. Now when the man was at rest on the stretch OA, can you guys see the stretch OA? Yes, no?
Yes, sir.
Give me a second, beta. I think I've lost my screen here. Let me see if I can bring it back. Can you guys see it? I hope you guys can see it. So the rain is uniform, is falling uniform. When it is at the stretch OA, the rain seems to be making an angle of 30 degrees with the vertical. Rain is making an angle of 30 degrees with the vertical. Can you guys see it better now? Yeah, I think you guys can see it better now. So determine the following. Let's start with number one. The magnitude of the velocity of rain, observed on the stretch AB, to the magnitude of the velocity of man on the stretch BC. Now, you might be trying to figure out what is the speed at which man is running. And remember that man always finds the raindrops hitting him vertically. So of course he cannot be running at the same velocity. If he was running at the same velocity, the angle that the raindrops would seem to make with the vertical relative to him will keep changing, right? But it's not changing. So obviously he's running at different speeds at different stretches. So once again, the question A reads, the magnitude of velocity of rain observed on the stretch AB to the magnitude of velocity of man on the stretch BC. Kinematics. For those on the watching us on the YouTube, if we have live students, please do ask your questions. I'll be more than happy to address them to the best I can. So let me quickly see. Okay, so if there are no students, then we'll carry on with the live class, with the discussion in the live class. Okay. Assume the velocity of the rain to be v, magnitude of the velocity to be v. Now for the recording, I'm going to turn off the camera just to lower down on the bandwidth requirement there. Manan beta, you are clear on how you want to approach it? Rachika beta, are you comfortable?
Yes, sir.
Chavi beta, you're okay?
So just trying it out.
Okay. In the interest of time, let's see if we can do this together, right? So, how are you guys thinking about finding the velocity of rain on the stretch AB from the given information? Let's look at stretch AB, right? So the rain is making an angle 30 degrees. So this is rain. relative velocity of rain with respect to man is vertical. At least the direction is vertical, right? And how do you find the relative velocity of raindrops with respect to man? There'll be V rain minus V man. Now we know V man is running along the slope like this. So what will be V man? V man will be pointed like this. Okay? Yes, Peter? And how much, what is the angle it's making? The V man with the horizontal? 30 degrees, of course. So V man is going to be making 30 degrees here. Which means that the V relative velocity of raindrops with respect to man is vertically downwards. Correct? Yes, Peterji? Is everybody okay there? So if this is 30, this thing was 60, this angle is 60, this is 30, then this must be 30. If this is 30, then you know what this angle is. So 60, so this is 120. So you can use the sine rule. So sine of, so let's say this is V rain. So sine of 120 divided by V rain is equals to sine, what are we interested in? Magnitude of velocity of rain observed on stretch AB. So we are interested in this V relative with respect to man. So we can write this as sine of...
Sir, can you explain this one more time?
Sure, Beta. You mean the diagram?
Yes, sir.
Okay. So let's say a particle A is moving like this, and we said B is moving like this. So if you want to find out relative velocity of A with respect to B, what do? You add minus B vector to this, minus VB. Why? Because relative velocity is nothing but VA minus VB, which you can think of as addition of two vectors, VA plus minus VB. Right? This is minus VB. Correct, Namita? That's how we do it?
Yes, sir.
If you are okay with that, then we're going to use the same logic here. So we know rain is falling at an angle of 30 degrees. I'm going to make it slightly bigger so that we can see the angles clearly. So this is V rain with respect to the ground. This angle is 30 degrees. Now man is running down the slope AB. So V man is along AB. That means minus V man is up the slope, right, from B to A. This is minus V man. So minus V man is like this. Now how big shall I draw it? Well, it should be big enough so that the relative velocity comes out to be vertical, because it says no, is always finding the raindrops hitting him vertically. So whatever was happening with V man, it should be in such a way that the sum of the two vectors, which is V rain plus minus V man, sum of these two vectors should be vertical. So this will be your V rain with respect to, or relative velocity of rain with respect to man. Is that part clear? Yes, Peter?
Yes, sir.
Then we're just using the sine rule, right?
Yeah.
You're familiar with that, no, Peter? So sides A, B, C.
Yes, sir.
Angle A, angle B, angle C. So sine A by A is equals to sine B by B is equals to sine C by C. So now we're interested in V relative man. So this is the equation. So we're going to find V relative with respect to man, that means relative velocity of drops with respect to man in terms of V rain. So that will be, what is sine of 120? That is cos 30. Correct, Nabita? So it will be V rain
Yes.
into tan 30. Tan 30 is how much? 1 by root 3. Now let's look at the stretch PC. It says magnitude of velocity of man on the stretch PC. Okay, there is a lot of clutter here, but I think we can still manage. So at on BC, so I'm going to erase this. So here, V man is in this direction. So in this direction. Okay, and this is V ray. We know some of these two should be vertical. So V relative with respect to man. This angle is 30. If this is 30, then this will be V man, magnitude wise, V man will be V rain sine 30. That is V rain by 2. So the ratio of the two would be 1 by root 3 to 2 by root 3. So this ratio will come out to be 2 by root 3. Okay, any doubts? I'll let you guys do the rest 3, but please do it. If you have already done such problems, don't worry about it. But if you have not done it, then I would encourage that you do it. And we will gonna stop the class in another 1 minute later. Any questions?
No, sir.
Okay. Chavi beta, you're okay now?
Yes, sir.
Okay. Manan, any questions, beta?
No, sir.
No, okay, good. So just to give you guys some heads up, so tomorrow we'll talk about the swimmer in the river problem, and then we'll actually go to our question types and we do it there, and then we're going to have some more fun problems. But in any case, good. So tomorrow we're going to be working from the website. So this is the very rare circumstance that we work off these blogs. We'll primarily be working off the website. You guys have a wonderful evening, and I'll see you guys in the evening, right, Manan? Ujika? Okay, beta.
Yes, sir.
You guys take
Thank you,
care.
sir.
Chavi beta, take care. Bye, beta. Bye.
Yes, thank you, sir.
Bye, beta. Bye.